our final session of the event. We're going to end with a bang. We're going to talk about how we do grading and assessment in CS50 and how that might also apply in CS50 AP. The way we grade things in this course is kind of unique, and we have found it to be really valuable for students, and so I want to share what we do, and then in the second half of the session, we're going to go upstairs and get together and actually look at some actual student submissions and just play around with this, the 4-axis model that we're going to be talking about. I'm going to leave this link up. Well, not going to leave it up. It's been up. You can keep submitting stuff to it, even though we won't have any more sessions after this, because your questions and stuff are always things I want to try and answer, and I might be able to answer them in an update or what have you. So that link will be up for a while, or that form will be up for a while, and you can submit any questions you have there as well. But for now, we're going to talk about grading and assessment. And also, before I forget, there was a question about final project videos, and the production team has kindly sent me a link to a curated list of some of the student videos that we've collected about their final project, and so I'll pass that on to you as well. So just want to close the loop on that one. All right, so grading and assessment. So as I said, we in CS50 don't grade things in the most common way, where I would argue that the most common way is probably points earned out of points possible. I think that's a really common metric. And there's also some standards-based metrics that I know are prevalent as well. But we use a 4-axis model where we grade each assignment in 4 different but interconnected ways. We grade them on scope, correctness, design, and style. And we'll dive deep into all 4 of those in the next hour. And when a student wants to know what their ultimate score is on an assignment, because everybody wants to get to a number, we use this formula. So these 4 axes are independent, but they are not equal. They're not weighted equally. And it's an arcane formula, and you don't have to write it down again. Remember, you got all these slides too, where we weight scope the most. We want students to, and we'll see that scope is about attempting a problem. We care the most about trying. And then from there, we weight, does the problem work? How well designed is it? And how good does the code look with less and less weight? So we're prioritizing trying and succeeding above other things like design and style, which when a student comes into CS50 having never done any coding before, I know that I certainly came into CS50 having done no coding before, and my design was terrible. And it is something that is, design and style are things to be improved upon over the course of the semester. And so they're weighted far less because it's a skill we want students to develop, but we don't want it to really knock their scores down. We don't want to hurt them because they come in with no prior experience. We grade everything in CS50 on a 5-point scale. Deliberately very rough. The reason for this is it's really easy to say, well, this is a 4, this is like roughly a 4, and this is roughly a 4. If you get into situations of, well, this is an 8, and this is a 9, or this is a 14, this is a 15, you're starting to get into really fine gradations, and it's going to slow us down as graders trying to make these categorizations if we're trying to like hash the students into various buckets. But a 5-point scale allows a good amount of grouping, clustering, but also enough to, there's a difference between something that's roughly a 3 and roughly a 4, and we can sort of describe them as, a 5 is excellent. A 5 does everything we want it to do. So a code that passes that runs through all the battery of check 50 tests and is all great stuff, that's excellent. You did everything this program was expecting you to do. You got a 5. Maybe if you failed 1 or 2 of the tests, I'm just using correctness because it's the easiest to explain. Maybe if you failed 1 or 2 of the tests, that's a 4. Like you got really close. There's a couple of corner cases you forgot to iron out, but you can get there. And then down and down from there. Rarely, even in CS50, I very rarely will give students even less than a 2. There's always usually something worth commenting and noting and trying to encourage students to improve from there. And as we'll see, these numbers are just part of the equation. There's also a qualitative feedback aspect to it, where I want to spend most of my time grading with comments, helpful feedback. What did you think about this? What did you think about doing this? Maybe this didn't work out quite so well. Here's another approach that you might be worth considering. So obviously the numbers are important. Students focus on the numbers a lot, but I try and spend almost all of my time with comments, so that for the next time when they tackle the next problem, they can take those comments into account and hopefully begin that upward trajectory. The mantra that we use in CS50 is that we don't grade students relative to one another. We take every student at the beginning and we plot out, or we examine their trajectory from beginning to end. And it's really how much do they grow as a learner. That's really the important thing we care about in the way we do assessment. And that can be tricky to fit into in a high school setting where there's standards and there's numbers and rubrics that have to be met. And we acknowledge that it's tricky, but I want to discuss how we do it here, because it's something worth considering, or worth maybe incorporating or trying to push back on those standards, just so that hopefully this will make things a little easier. I saw there was a question.
Yeah, it just popped into my head when you said about telling them, did you consider this? This is the grade. It's not an iterative process.
Correct. This is after the fact. So, in CS50 AP, when we redesigned the course website so that you have these templates, this will be the point where the solution has been released, where there's post-mortem, where there's a video explaining the solution. So at this point, there is no opportunity to go back and do it again, at least in CS50. And that's also partly because we have a 13-week semester and we don't have the time to double back. But I could very easily see this scale being implemented where Part A is you have a discussion about it. Part B is you turn in a pseudocode implementation, you grade the pseudocode, and then they do have this iterative extra part where they can try and translate it into code. That's a time luxury that we can't afford, but that I would encourage, if it is one that you can afford, or you want to implement half of the curriculum in a year, and so you do have these extra times to go back and iterate on this to get these marginal improvements as you go, definitely would recommend it.
Is there any way that you could measure the amount of time a student spent on the IDE working on something?
There is. Every file has a file revision history, and we didn't get into detail about that stuff last night because I could see everybody was tired, and I was tired too. But
is that part of the scope?
We don't consider how long somebody takes on something. It's really just about did they make an earnest effort. But we don't keep track of how long it takes, because what is an earnest effort? It depends on the student, right? If somebody has a lot of experience, they might try and succeed in 10 minutes. Another student might try and fail, but they tried over the course of 6 hours. In my case, both of those are perfect scope scores. They tried relative to their ability to do the best that they could do. So those would both be 5s in scope.
And I know you can't, as far as you guys go, if you can never get the program to run, you get it as good as you can. You can't upload it to the website. Can you do that? Can you do it for, or can you?
Yeah, you could. I mean, you could
so
upload.
You could upload one that was partially.
A student who had who took a piece of paper and drew out a flow chart explaining what they wanted to do, even if they couldn't reduce a single line of it to code, they tried. And if they tackled every part of the problem and thought about everything, even if they didn't know how to reduce it to code, that would be scope. That's the effort. It shows that they're engaging with the material. It shows that they're in their own way, even if it doesn't reduce to, it wouldn't score very well in correctness because nothing's going to be able to run. But that's why these activities are independent, and we still want to reward that effort strongly. So let's go into some detail about these things. We've already started talking about scope, and scope asks the question, to what extent does your code implement the features required by our specification? Did you try? Did you try and get your code or your pseudocode or whatever you have to roughly match what we asked you to do? So if we asked you to print out a Mario pyramid, so if you've all looked at problem set 1 on edX, if we asked you to print out a Mario pyramid of size, n, did you in some way, whether it's in code, in pseudocode, in a diagram, show me that you thought through all of the steps that would be involved in doing this? You get a 5. That's really all it boils down to. And so when I talk to my students at the beginning of the year, and this isn't so much applicable for CS50 AP as we'll see in a second, but when I talk to my students at the beginning of the year, this is the second section, so they've met me once, and then they get their first problem set back, and then we talk about how the course is graded. I tell them there's no reason you should ever not be scoring a 5. You should always be trying. If you're not trying, why are you here? This is a course, right? There's always, effort is always required. In any course, you've got to try if you want, or else you don't really want to be there. And if you don't want to be there, then you're not doing yourself any favors. So I always say, if you don't get a perfect score in scope, you're not trying, and we don't want to see that happen again. In CS50 AP, The reason I say this isn't applicable is in CS50 AP, we actually don't always recommend that you grade on a 5-point scale, and the reason for that is the difference between a problem and a problem set. So at Harvard, we have 9 problem sets, which comprised of 3 to 5 distinct problems, which allow for these gray areas in between, where you might get a 3 in scope because you tried problems 1, 2, and 3, but you didn't get to problem 4. That doesn't really happen so much in CS50 AP anymore because each problem is its own distinct unit. And so I still recommend that there can be a gray area, although that gray area might be questions of academic honesty. It's really very ill-defined. Typically, this is sort of this is a bit, like this is a Boolean value. It's true or false, try or not. But I can conceive of situations, however obscure, that might merit a gray area, or if the problem is comprised of multiple functions that a student has to implement, for example. Maybe they tried to implement 2 of them, but not all 3 of them, and so maybe that's a 2, sort of on a case-by-case basis. But a student should always be trying. So
you don't do it based on, like, did they try each part of the specification, and that's where the gradation?
That's where the gray area might be. For the early problems, there's usually only one thing they have to do. But once you get into units 3 and 4, the problems are like, write these 3 different functions. And so that's where these gray areas become a little more, a little less gray and a little more black and white. So yeah. So questions on scope. We really do consider scope to be the most important thing, because even if a student is trying, even if they're not succeeding in the way that we might classify success, that's still a lot of intellectual engagement with the material and should be rewarded.
You go over all of this in class?
We talk about this briefly in lecture, and then I devote a good chunk of my second meeting with the students. So after they've received their first graded assignment, I spend a good amount of time. And this is also at the top of every specification, explains how we do grading, but I get into even more detail about how I do grading and what I will expect of them and what it means to, why I rarely, if ever, give a 5 in design, and we'll talk about that in a minute. So I have this supplementary thing. At a high level, it's mentioned in the syllabus, it's mentioned at the beginning of every specification, but in terms of in-person, it's mostly with the teaching fellows. So the second axis is correctness. Correctness asks the question, to what extent is your code consistent with our specifications? So not that you tried to implement the features, but did you actually do what we asked you to do in terms of the outputs being generated by your programs? And is your code free of bugs? So if I ask you to print out a Mario pyramid of size 20 and yours prints out a pyramid of size 19, or if I ask you to print out 15, you print out 14, you clearly were on the right track, you tried, but your code's a little buggy. You have a small off by 1 error in there that needs to be dealt with. And so you might not get full correctness points, but you probably get full scope points, or you definitely get full scope points if you're printing out something that close. And generally when I talk to my students, this is what I really recommend for them in terms of where they should be landing. So 4s and 5s, that's great. If you're consistently getting a 4 or a 5, you're doing really well. You're getting really close to the solution. Either you're getting the whole thing or you're just off by a teeny little bit. You probably just ran out of time. If you had an extra 20 minutes, I know you would have got it. Like you're in the blue. You're in a good spot. Stay there. Keep at it. It's okay to land in the yellow. Like sometimes you have a bad day. Sometimes you have a bad week. It's a 2 or a 3 is a very respectable score. 3 is good. That's what we said right at the beginning. 3 is a good score. So when you see that something is out of 5, if you get a 3 out of 5, and I inevitably have students every year who are like, I got a 3 out of 5. Like that's a D-. It's not a D-. It's a different perception. It's maybe something you're not used to, but 3 is good. 4 is really good. 5 is great. Like, get into that mentality of 3 being good. Don't think of it as a percentage of something. So if you get a 2 or a 3, like, you're still doing good. You still made efforts. You still got a good chunk of the way there. You don't want to keep landing in that zone. You want to get out of the yellow and back into the blue. But it's all right to be there. Like, you're doing all right. You generally don't want to stay in the red zone for very long. You don't want to keep turning in code that is completely broken, because at some point, even though you're trying, hopefully at some point it's starting to click just by virtue of it trying over and over. And when I run into students that are getting 0s and 1s consistently, which is rare, this is the point where I would pull them aside and have a more detailed conversation about what's going on. What can we help you with? What can we try and do to provide extra level? Can we get you tutoring? Try and throw additional resources that we have at the problem to get the student back to a level of comfort and back up with their peers as well. So to help with correctness, we provide students with a tool called Check 50. We talked about this yesterday. So Check 50 is a command line tool. It's built into CS50 IDE to run automated unit tests or automated checks of students' code that we write. As I mentioned yesterday, as I alluded to yesterday, we're in the process of revamping this tool right now to also allow you to write your own unit tests for your own problems if you want to supplement. So right now that feature is not available, but it is something that has been in the works for a while, and especially now that we might have this ability to plug in with Cloud9 and possibly interact with Gradescope to do something like this. This seems to be becoming more and more of a reality and more of a short-term thing, so fingers crossed we'll be able to have that lined up for fall as well. But even if not, we still have this huge battery of problems that can be used with Check 50. For almost all of the problems in the course, there is a Check 50 available for students to benchmark their code. And using Check 50 is not submitting your code. It is a way for students to proxy how well they are doing and realize what things might be going right and what things might be going wrong. As a teacher, I use Check 50 after the code has been submitted when no more changes can take place, and I'm running the same battery of tests. But just because a student is submitting through Check 50 or running their code through Check 50, that is not itself a submission.
They can run it many times?
They can run it as many times as they want. We've flirted with the idea, or I consider the idea of time restrictions so that students aren't just treating Check 50 as their compiler. But for now, I think that might be a little heavy-handed of a tactic. Jack?
What does it do?
Check 50?
Does it say, given this input, this is the expected output? Or?
Yes, I'll show you the sample output, but basically it's a diff of if we run it through this, does your solution match the staff solution, which is already embedded into Check 50. So it benchmarks it against the outputs of the staff solution.
Maybe you can run some kind of example.
I can show you an example of what it looks like. I could probably try and run one too, but I don't think I have any sample code lined up for it. But I'll show you what the output looks like.
And this is the same that is explained when you do the PSATs, and they have you.
Yes, and how to use Check 50 for every problem is outlined in the specification, so students know exactly how to use it for this particular problem. My sort of catchphrase is that Check 50 is used to grade correctness, but I don't always use its output exactly. It is suggestive, not determinative. And the corner case here is if you have a student who's worked on the greedy problem, and I have seen this, and that's why I can tell you this, the code itself looks like this. If f equals 0.20, printf 2, where they basically just line up all of the benchmarks that we outline and have caught them all in conditions. So Check 50 in that case would be, yay, hooray. But when you actually look at the code, you're like, no, wait a minute, I'm not sure this is quite right. So 99 times out of 100, Check 50 is going to benchmark correctly. But there's always that extra look we have to make sure there's no funny business happening. Happened a couple years ago. And as I mentioned, there is a revised vision in the works to allow for your own benchmarking. So this is a sample output for Check 50. This was Check 50 as run at CS50 for the fall 2014 slate of benchmarks for the greedy program. So as you can see, this student's code, and we don't see the code here, it would be up in the window up above, but a student would just type this line, and this is in the appliance as well. This is an older screenshot. I didn't make a new screenshot this morning, but basically Check 50, and then that string right there with all the dots in it, that's the benchmarking, that's the unit test that the student is running, so that's embedded in Check 50. So if a student types 2014.fall.psat1.greedy, they're running the battery of tests that applies to that iteration of the problem for that year. And then the student passes in their greedy.c file, so that gets uploaded to the Check 50 server, compiled on the Check 50 server, and then the two staff solution and the student solution run side by side, comparing the outputs. So in this case, the student would get a 5 in correctness. They passed all of our unit tests unless the student had done the trick where if it's 0.41, printf 4. We wouldn't want to see that. This might be a case of a student who runs Check 50 and is passing most of the tests, but they're failing one of the tests. And we tell them that what the expected answer is, the staff solution is outputting 22, but your solution's outputting 18. Has anybody done the greedy problem yet? Do you know what? So each of these tests is designed to catch a particular corner case that a student may or may not have thought of. Do you know what corner case we're testing right here? Yeah, we're testing floating point imprecision. So quick explanation of floating point imprecision for those of you who are not familiar with the term. Numbers are represented in binary, and it becomes impossible when you're using only zeros and ones to represent fractions precisely because we have a limited number of bits. And so the system has to round to the nearest number that's close enough for almost all purposes. In this assignment, though, the closest number to 4.2 is 4.199999 stuff, which for almost all intents and purposes is 4.2. But in this problem, when you multiply by 100 and then divide to truncate, it cuts off. So it turns into 419. And so in this case, the student has not rounded after they multiply. So this is the corner case. And we allude to the existence of this corner case in the spec and encourage students to be mindful of the fact that this is something they will deal with. And as a teacher, you know that this is what we're trying to test. Students don't see that that's what we're trying to test. They don't know that here we're testing the floating point imprecision case, but you know, because we provide the materials, that like this is what we're testing. The first couple are usually just random basic tests. We test then numbers that are larger than 1, whole numbers, to see whether a student accidentally treats them as cents instead of dollars, negative values, and so on.
We know because you provide documentation?
For you,
We
yes.
check for that. Okay.
But so yeah, all of these checks are designed, and so students get immediate feedback as to what aspects are right or wrong. And also, if you're debugging with a student and you have looked at this beforehand and you have them run check 50, if that's the one that's being flagged, you can immediately home in on that portion of the code and be like, maybe you're not, tell me about what you're trying to do here. Like what might be going wrong, and you can sort of isolate the portion of the code based on what checks are failing, if they're individually. Sometimes you might get something like this that's a little less helpful, but usually these ones are actually pretty easy to solve, this whole cascade of when you get frowns and then I have no idea what to do. So in this case, the student just passed a file called style5.c when they should have been passing greedy.c, and so when it compiled, the makefile had no idea what to do. It couldn't benchmark the two things side by side. This commonly comes up in the Caesar problem, for those of you who've gotten to problem set 2 in edX, because for whatever reason, we've chosen a very difficult to spell word as part of the assignment name. And so you get Caesar with one A or with the E and the A backwards. That happens a lot. And so when you run check 50, it's like, oh, that's not right. And so you just rename the file, and then it runs perfectly fine. So that's basically what the output of check 50 looks like. It's very, very straightforward, smiley face, frowny face, or confused face because there is some precondition that has not been satisfied, which is usually only the first one. But yeah, so students have really simple feedback, and then from there they can iterate and iterate on their own code as well. Okay.
One question: is it possible to create some kind of problem or visit for our student and use the check 50 to grade it? Or?
Not as it exists right now if it's your own problem, because the way it's designed is over several years we've just sort of kludged a bunch of stuff together to make it work. We didn't really think about it being adapted. When we originally designed check 50, this was not a project we had in mind of other teachers implementing and adapting it. And so right now we're in the process of rewriting the tool so that it can be benchmarked with standard tests like 2014.fall, but also you could provide your students with your own batch file and have them run that instead. So one of the interesting things about scope and correctness, so I said it's really important to grade all 4 of these sort of independently, but scope and correctness oftentimes go hand in hand, and usually if a student's code runs perfectly, they probably also got scope points. And so it can be a grading shortcut where if students who immediately pass all the tests or are passing almost all of the tests, you usually can glean without even having to consider the code or look at the code at a high level whether or not they've tried. If it works, they probably tried. If it's close, they probably tried. And so that's that's a nice aspect of these two metrics being side by side. But outside of this corner case, we really do try and grade them independently. So a code where the student tried, but it's totally busted, but their idea was pretty sound. So now they have gotten good scope points, no correctness points, good design points possibly because they had a good idea. They had a good approach to what they were trying to do. Or maybe if their code was totally broken, but it was really easy to read and there were a lot of comments in there and it was well indented, like they might be getting full style points. So they can still score really well on 3 out of 4 axes. And the reason that we recommend that you grade them independently is that we don't want to keep hitting students over and over and over because there are these 4 different axes where, especially where they're weighted differently. If a student doesn't do well in correctness, we don't want that to cascade down into style so they get hit like again and then cascade into design so that it's like triple jeopardy, right? They're losing exponentially more and more points because of a mistake. So we try and grade them all in a vacuum so students can get as many points as possible for all the different aspects we consider. Design. So design is always the hard part to talk about because, well, first of all, I asked the question, to what extent is your code written well? I guarantee you in this room there are 20 different definitions of what it means for code to be written well, and I guarantee you in your classroom there are 30 different definitions beyond yours of what it means to have code written well. And indeed, design is the most challenging for us because it is the most subjective of the 4 axes. What I think is good design might be different than what Colton thinks is good design, and that's not a problem. The important thing is to be consistent in your design philosophy, and we outline in the specifications a number of design philosophies that we think are good, which are meant to be a non-exhaustive list of possibilities. And frequently, there will be cases, at least once a year, where I will see a solution I've never seen before, and it's like very eye-opening and really cool, and that would score well in design. So that's clever. Like I never really thought about tackling it from that perspective. I like that idea. Even the idea of, it came up yesterday with when we were drawing the cube, and then somebody said, draw a regular hexagon. I didn't see it as a regular hexagon. That's an interesting design approach to solving this particular problem. That's a really, that's sort of the creativity that we try and reward when it comes to design. So design is also changing. So there was a time when go-to statements were considered good style or good design. But when I was grading one of my students' assignments last week and they used a go-to statement, I did not reward it with good design points because the go-tos are, you're immediately jumping out of subroutines without letting variables finish. You could be doing something dangerous. It's not a good thing. You could be leaving memory unallocated, or you could be leaving allocated memory unfreed. It's sort of a hard stop. So go-tos are considered bad is sort of the bullet point to remember from Doug's conversation. Doug hates go-tos. But there used to be a time when these were considered good, and so what was good design is not necessarily good design in the future. So that's something to keep in mind too, and that's what makes it difficult. And we're starting to get to the point where machine learning is soon going to be able to help us with this. We're not quite there yet, and that's why this axis is not automated. But there, I think, will be a time in the near future where machines will be able to assess code and group them in a way that doesn't cost an absolute fortune in some sort of easily digestible format. So hopefully in the near future, we'll be able to clear this bottleneck, which is our bottleneck. At CS50, this is the bottleneck for grading because it is almost entirely qualitative. This is where the comments are, and this is hard. And I don't have a silver bullet because it's hard for me. I've been doing it for 9 years. It's still hard. There are still questions that I have to think about. Weighing different options. Is this a good design? Could this have been done better? But this is also where students will benefit most from your qualitative feedback. You writing a comment like, on the correctness of something, they probably already knew that it wasn't broken. And maybe you can explain, you can give a little bit more of an elaboration as to why it was broken. But here it's, why might this approach be different than another? And we'll go through a couple of examples from the greedy problem of a couple of different designs just to show you, give you a sense of what a good, better, best design might look like. But my answer is not necessarily the definitive answer, and it's certainly not the definitive answer.
I was going to ask you if you dock them on design points if they used a for loop to solve the greedy. Is that what you're going to?
Yeah, we're going to, exactly. So some questions to consider when you're grading design or when you're thinking about your comments for design. Do I see repetition that could be eliminated? Do I see loops that could be eliminated? Are there magic numbers that can be eliminated? In fact, if I was grading my own slides, I might say, well, maybe what I could say is, can I eliminate repetition, loops, and magic numbers? So there is less repetition. That is probably a better designed slide. I thought it was going to get a bigger laugh than it did, but that's okay. Thanks. Thank you for that pity laughter. But things like that, where you're factoring out things that would be repetitious over and over, like that's an improved design. It's easier to read. You're not seeing the same expression over and over and over. And similarly, in our code, do we not want to see the same expression over and over and over if there's a way to factor it out? Is there a shorter way to accomplish the same thing? as a general rule, this does not always hold true, as I'll show you in a little bit. Shorter code is usually, but not always, better designed than longer code. So it's by virtue of the fact that there is less to process, it's probably more efficient. Should certain parts of the code have been broken out into its own functions? Is it something you keep going back to or doing over and over and over that's maybe really long and bulky? And maybe if you took that and split it out into its own function, it might improve the flow of things otherwise. These are all questions to consider. And I sort of alluded to earlier the fact that I very rarely, if ever, give a 5 in design, because there's almost always something that can be done better. And in fact, every year when I redo the problem sets, I almost always find a way to improve my own implementations. And so I would not even give myself a 5 in almost all circumstances. There are a couple of cases, like especially in the early problems, where it's pretty silly not to give a 5. But later on, it's like, well, what about doing this instead? Or can you? Or sometimes I'll even ask a student to, and this is something that I am able to do that you may not be able to do, is I'll give a student a 4, and in a comment I'll say, defend why this is better than doing this. And if they make a strong defense, I'll change their score back to a 5, or move their score, if it was a 3 to a 4. Have the student defend their design decisions to me, because even that process of, even if the defense fails or is not a viable defense, they're engaging in another level. They're not just writing code. Now they're thinking about their code. They're analyzing their code. They're analyzing the good and bad of different situations. So let's look through a couple of examples of design that you might have seen in the greedy problem. So this is an assignment that, or this is an implementation of greedy that I might consider a good design. Why is it a good design? And if you haven't done it yet, well, academic honesty is important, so just keep that in mind. Why is this a good design? Well, it solves the problem. That's more of a correctness question, but it does solve the problem. There's this loop, and if my change is greater than 25, then I will subtract a quarter, and then I'll go back around again. But the reason it might be a good design and not a better design or a best design is that I have this one huge loop, and in the course of this loop, I have 4 Boolean expressions that I might have to check as I cascade through. So at the very beginning of this loop, I'm always checking, is change greater than 0? Then I'm asking a sometimes redundant question, is change greater than 25? And then if it's not, I have to ask another question, is it greater than 10? So by the time I get, maybe when I'm down near the very end of the problem, if I'm down to 3 or 4 cents, I am asking 4 questions before I even fall down to the final case of just simply knocking pennies out of the problem, right? So that's a lot of questions to have to ask to do something relatively simple as handing out coins. There's also this coins plus plus line that appears in every single one of the sort of sub-expressions. But I could factor that out as common code and already make a design improvement. If in all 4 branches of that code, I'm going to hit the same exact line, a design improvement is to, just like I did with my slides with the do I see repetition, take that same line and pull it out so that it instead will happen still on every iteration of the loop, but I don't have to have the line 4 times. That's just a very simple example of a design improvement that students can usually grok onto pretty fast, just seeing the repetition go away. And it's something that I generally try and point out particularly early, is if I see the same line of code appearing multiple times, but there's a way to do it, just to take that out. So here's an example of a better design, in my opinion. And again, your opinion may differ, because this one, instead of having 1 loop, has 2 loops. So maybe that's not immediately comes to mind as a better design. Well, it still solves the problem, but now each of the loops has 1 task. I don't have to consider many different pathways through my code. I'm just going to keep asking the question, is it more than 25? Is it more than 25? Is it more than 25? Keep asking and asking and asking the one question. Then when I'm done, I'll ask a different question over and over and over without having to fall through and consider possibly 4 different questions just for every time I want to increase the number of coins by 1. There's also a couple of clever optimizations here, right? Like, you can never have more than 1 nickel. If you have 2 nickels, you could have just given away a dime instead. And so we don't even need a loop for that. We can just have a simple conditional expression. And at the end, it recognizes that everything that's left behind after you've taken away all the quarters, all the dimes, and all the nickels, it must just be pennies. So however many pennies you have left, you don't even need a loop to iterate through those. You can just say, well, I have 4 cents left, so I have to give away 4 more coins. And so it's just a couple of small optimizations that make this code a little bit better. Now, to get to the question that was alluded to earlier, is there a way to do it without using loops at all? And the answer is yes. And this is not something that I would necessarily expect students to do. You know, this is stuff we cover in Unit 1. Students know what plus is, they know what modulus is at this point. But this isn't necessarily something we would expect a student to be able to immediately glean, but that's okay. This might be a 5, so a student might have gotten a 4, but now we can say, hey, take a look at this solution. Think about this. Think about the clevernesses that are embedded here. And even if they don't get a 5 on this assignment, it's still something that they can think about. Maybe they can get a 5 on the next one because they're seeing something here. It really is about a growth trajectory. We're not expecting students, and it very, very rarely happens, that students are getting 5s across the board throughout the semester. It's definitely, and somewhat deliberately, more like this is what we're trying to do. We're trying to start them out, say, you know, you're doing good, you're getting 3s, and now you're getting 4s. And sometimes you might be getting 5s near the end of the semester, but there's almost always this upward trajectory because it's learning from past experiences and iterating upon it. And so this solution is pretty cool because it solves the problem, and it doesn't use any loops at all. It uses C's integer division rules, which are, I won't get into now, but it deals with the truncation of numbers versus the rounding of numbers, and you can leverage the remainders and so on and so on. It's really short. It's 7 lines of code. The first one was 23-ish lines of code. The next one was 14-ish. Now we're down to 7 lines of code. And as I said, code length is usually, but not always, a good proxy for design.
So would you have given the previous example a 4? Or
I would have probably given it a 4. But in a high school setting where this problem is out of 3, I would have probably given this a 3.
I got you.
Because I have a few more points to work with, I can be a little harsher. In a high school setting, I'd probably give this a 3. In college, I would give this a 4. In a high school setting, I would give this a 2. In a college setting, I would give this a 3. And in both cases, I would give this a 5 or a 3, college and high school level. The last time I gave this presentation, Nacho's colleague, Bjorn, who also works at Microsoft, I said, is this perhaps a better design? It's fewer lines of code, and I argued that it was arguably a better design. And it turned into this hilarious discussion, and I still joke with Bjorn about it all the time, that he kind of railroaded me in a presentation where I was like, yeah, this is a better design. He's like, no, it's not. And it was really, and it turned into this great moment that we are not replicating now, but I'm telling you about it, because it really illustrates the point. It really illustrates the point that there are very different definitions of good design, what a better design is. Like, this is 6 lines of code. I think that this is particularly clever. But if you saw this at Microsoft, apparently, this would be so arcane and ridiculous that it goes too far. It's too clever by half. And it becomes too hard for someone to parse. And so this is fewer lines of code. It's 6 lines of code. And my opinion of this has changed. I did it to be clever, and then I realized that Bjorn had a good point. And so my philosophy of design has changed, that this is fewer lines of code. And yeah, it's clever. It's using arrays. It's being a little more advanced. It's being a little tricky. But maybe it's not necessarily better. It could be better. It could be the best implementation out there. There's probably even better implementations out there than this. But just goes to show that there really is no right or wrong answer when it comes to design. There's a lot of different implementations. So, Nacho, make sure to tell Bjorn I told that story again. Okay.
So is better design better for the machine or better for humans?
Better design. Design is something that I would consider changes to the code that impact the code's performance are design related.
But what about performance memory-wise?
We're having the discussion again.
Sorry, I guess as a software engineer, I'm like looking at this stuff because I'm like, yeah, arrays, that's like so much extra memory.
Exactly.
But this is clearer to me as a human than say the last one. And so I guess I'm curious
Really?
what you guys optimize. Well, yeah, because this to me is like moving through iteratively, whereas I think for my students, for example, the concept of mod is very conceptually difficult. So I totally appreciate, I think it's clever, and I think maybe 1 or 2 of my students would have thought to use mod. And if I were in a code review, they probably would have said, hey, no loops, because at least on Outlook, like iteration is expensive as opposed to like memory, right? So I guess I'm just curious what you guys think about when you say optimizing. Do you mean for memory? Do you mean for runtime? Do you mean for humans?
That's what I was saying.
Yeah, and I like this one because it would be much easier if you now said, okay, implement this at, for 50-cent pieces and dollar coins. This one's real easy to do that. Just change 3 to dot length
Yep.
or whatever it is in C. And
So it's
so I would really like this one, but.
This is what I mean. I love this discussion, and there's no answer. I mean, in some cases, maybe it is memory usage, and sometimes maybe it's runtime, and that's sort of the beauty and the curse of design is that we can have. And I'm so glad this discussion started again because it just goes to show you that even though I will outline for you a number of things that I think are good designs, there is equally, almost always, a sound counterexample, and that's why I'll challenge my students to defend their decision. And if they make a strong argument, I'll change the grade, and I'll.
In the AP Computer Science A, they never are concerned with.
This is not even touched on in A.
No, but I meant they're never. Well, I mean, when the graders, when the College Board grades the thing,
Mm-hmm.
they never worry about memory or speed or anything like that. Is it clear to the reader?
Mm-hmm.
That's what they're after. How about? I mean,
Actually, does it work is what they're asking.
Yeah.
well, right, but in terms of
However it works.
in terms of
It can work
penalties.
anyway.
No, I disagree. That's not
I've
what the
done
readers
it,
have
it can
told me.
work anyway.
Yeah, I've read two. I read last year, and we parse every problem how it's written, and if it results in the correct answer, you are given credit.
That's funny because I've had.
I
I've had
I
readers
did a
tell me
string
that-
problem last year, and students took every character of a string and stored it in a char array, and didn't use a single string method.
That's interesting
To
because that's not
solve
what
a
I've been
problem.
told before, but that's.
And my poor brain
not gonna tell my
walked
kids
through
that, but-
solution.
Well, I don't have experience as an APA grader. When I consider the distinction, which is often sometimes subtle, between design and style, design are impactful of the machine, and style is impactful of the human. So is your code easier to read? I consider more of a style question than a design question. So that's, I think, where Bjorn and I disagreed, and that's where there's some disagreements here as well. And it's good. It shows that this model is not perfect, but it tries to cover different. It tries to create more well-rounded thinkers about code as opposed to just right or wrong. There's also the why question now gets added, and the how question gets added.
And for this class, what's beautiful about this is when you could have a Skype with a SME on what is the code review process in a large organization. How does Microsoft encourage their
And that has happened as far as
software
I know that's happened quite a bit. So.
Yeah, happy to help with that. Yeah,
Yeah, because each company has its own culture about what's expected and
Yeah, and each product really, I mean, like I said, like I worked on Outlook web apps, so it was all about like fastness. How can we get the code onto your screen, versus mobile developers. It's all about memory, and that varies so much between product, and that's something to keep in mind, and that's an interesting point of view for students, like, oh, what my code is gonna actually run on, so. Might be nice.
So that's an experience, hopefully, that you can bring to your classroom.
One thing that came up in the questions, like when you asked us about teaching this class, was that perhaps what would happen if somebody in your class knows a lot more than you do, or something like that.
Yep. Are you comfortable with a student knowing more than you do? Yeah.
But how do you grade something if they did something like absolutely crazy that you don't even understand?
I have the luxury of more time, and I try and understand it. I love seeing stuff like that, and it just makes me go crazy researching it. I'm an information junkie, so I don't know. I think that varies on your comfort level as an instructor, honestly. I love it. I love when a student does something that I have no idea what's going on. It clearly works. I'm running it through Check 50. It works, and I have to spend a good amount of time picking it apart, and it happens, and it's cool. I think it's really cool. What do I do about design?
Would you give them a 5 in that instance if they did something like?
So that's starting to get into a lot more case-by-case stuff than I want to get into, but what I would do is I would research the problem, and then based on what I'm seeing, once I understand what's going on, if I can think of a way to make it better, now having this newfound knowledge myself, I might give it a 4 if I can make it better. I have a reputation for not giving 5s, but it's meant only as it's a tough love tactic. It also tries to hammer home the point that there is no such thing as perfect. There's always ways to improve. So it's a philosophy of mine. But anyway, we're getting far afield. In terms of design, 3s, 4s, and 5s are really good. Students are landing in 3s, 4s, and 5s for design, and this happens almost all the time. That's where you want to be. 2s are okay. Like sometimes you have 3 left feet and you're tripping over it, and that's okay. It happens sometimes. You hopefully can provide some qualitative feedback, and they'll be able to leverage that and get back into the blue range soon. Zeros and ones, again, I would talk about ways we might want to get a tutor or talk to them about if there are concepts that they are struggling to grasp, how we might be able to help reinforce those so that they can do better in future assignments. And in the AP scale, 2s and 3s for design would be good. 1s is the area that's sort of the bubble area. Zeros, again, I imagine zeros to be extremely rare. I mean, if a student is trying, they're probably thinking to some aspect about design as well. And so it's really rare for students to land in these red ranges, honestly, because just by virtue of trying, they're getting part of the way. Correctness is being the only example where it can be very clear-cut, right or wrong, but the other 3 can definitely be, you can usually score some partial points along the way. And then style. Style is sort of an easier question. To what extent is your code readable as a human being? I always tell my students, if you make your code really hard for me to read, bear in mind I'm your grader, and if you make it impossible for me to read, that might reflect poorly on your style score because I just can't parse through what you're trying to do. If all of your code is left aligned and you have all these braces and everything, I am going to struggle to, I'm going to do the work to do it, but you're going to rub me the wrong way, and I'm not going to be happy about having to do all that work, and so your style score is going to reflect my frustrations. But this is something that's really easy to instill in students, and we also have a tool called Style 50, where a student can run their file through this tool, and it will output a smiley face, a simple smiley face, if it's generally consistent with our style guide, and we do advertise what our style guide is, recognizing that there is no one absolute style. In fact, I'll jump back a few slides and show you that this style, where the braces align the way they are, this is not CS50 style. It's A, partially because I didn't want the text to be this big, and B, that's the way I learned how to do it. When I started coding, it was braces on the same line. In CS50, the braces come below the line. But that's something we tell students about. They have access to the style guide, and Style 50 is designed to check their code to see whether it's consistent with that guide. But we, of course, recognize that there are many different ways to style one's code. The most important thing is consistency. Because there are many ways to style one's code, there is a degree of subjectivity into this, but you can use Style 50 as a grading proxy to make the assessment of this particular metric quite a bit easier. If you get a smiley face, it's probably a 5. If you're getting 1 or 2 comments, it might have a comment like, line 8 is indented 8 characters, it should be indented 4. Maybe they just tabbed in too far. It can also say, there are way too few comments relative to the length of this code. So it can provide sort of feedback like that, and that can be very helpful in terms of making your style grading quite a bit easier.
For example, my student usually declare the variables in Spanish language.
Okay.
Maybe this kind little problem.
I'm so glad you brought that up because it gets me to tell me one of my other favorite stories. So we used to have a problem set. Is anybody familiar with Huffman coding? So you build a Huffman tree. And so this is very late in the course. It is something that we offer as part of Unit 6, which is one of the optional units, Huffman coding. And so students have to construct a Huffman tree, and we provide an API for something called a forest, and they can plant trees in the forest and pick trees and this whole thing. But this student was one of my strongest students, and he often fell into the too clever by half trap. And in this case, he named his variables after Norse gods of mythology. And so, it was like Yggdrasil, it was like YGGD, like it made no sense, right? And his variables were not aptly named, and there might have been an accidental mix-up of 2 of the variable names because he was being so clever, and his code was totally busted and he couldn't figure out why, and it was because he had mixed up his variable names because he was being so clever. And so questions when we talk about when we're considering style for human readability are, can I tell what your code is doing, and do your variable names make sense? If you're measuring the height of something, you probably don't want to call it width. I've seen that before too. Is your variable name easy to understand? If I didn't understand C, this is actually a question I ask a lot, and I can see the flip side of this being true as well, is if I didn't understand C code, could I read your comments and generally have an idea of what your code is doing? If I can't, you probably don't have enough. I should be able to read your code as not so much in every granular level of detail, but I should roughly know, like, in this part I'm doing this, in this part I'm doing this, and I should be able to generally follow what is happening in your code.
Have you ever tried having them write the comments first?
I encourage.
Someone suggested that to me a long time ago, and I've never actually tried it, but hearing you talk now, it sounds like, so they pseudocode, diagram, whatever on paper, and then they sit down and actually this teacher had them type all the comments before they then put in the for loops or whatever.
So yesterday during the end of our Arturo section, I talked about I do, we do, you do. So in the we do part, it would be, let's take the pseudocode we came up with and let's create just comments, what we want to do, and then knock out those comments, or below those comments, put the code that is appropriate for what you're trying to do. So I actually mentioned that very early. I'll say, take your pseudocode and make your pseudocode your comments. Because even again, if a student turns in pure pseudocode, that's still scope. So I've seen that happen sometimes, or parts of the assignment, they're like, this is what I wanted to do, I couldn't get it, here's what my general thought was. So yeah, strongly encourage that for sure. The flip side of that, and this is a delicate balance to strike, is are there so many comments that I'm distracted by their presence? There have been times where a student will write a novel to cover one line of code, and then a novel to cover the next line of code. And at that point, I have to struggle to, I have to turn the comments off just so I can read the actual code. And that's a balance to strike, and I would strongly encourage erring on the side of too many comments early, just to get in the habit of making them in the first place, which is something that a lot of folks don't do. And then start to encourage it, scale it back a little bit. Be like, this is great. Can you maybe consolidate this into a single line that maybe details what you're doing over these 4 or 5 lines of code, so that you can just give me a general idea, as opposed to narrating the 8:58 p.m. when you wrote this particular segment of code. And again, if you can answer yes to any of these questions, it's probably not a perfect style score. This is, again, more of a philosophical thing. If there's too many comments early on, I would still, and Margaret, I think it was unit 3 is when I'm trying to remember all the grading metrics, but I think it's unit 3 is when I start to say, if there's commenting too much, start to deduct for that. I think it takes a while before we start to deduct for it, because we want to get students in the habit of writing comments at all. But the reason that this is never a problem is that students also quickly realize that style points are really easy points to pick up. If all else fails, you can make your code look pretty and get 5 points in style. And so students will very frequently go for those 5 points, even if nothing else, because it's some number of points. And so there is a motivation in that sense as well. And sort of to Joseph's point, good style makes coding errors easier to spot. If your code is really neatly aligned and you have good variable names and you are well commented, if you're trying to figure out what's going wrong in your code and you're reading your comments and it's incongruous with what you've written in your code, or your variable name doesn't make sense, or if all your code is aligned to the left, it's a lot harder to determine where the blocks of code begin or where the boundaries of a loop are. And so just instilling this good style philosophy can really make a difference in just a student's ability to debug without even having to get into a debugger or anything like that. Just looking at the code and be like, oh wait, that's not right. That, I have an extra curly brace there. That's not supposed to be there, and it kind of threw off the whole flow of the rest of the code from this point forward. So in terms of style, 4s and 5s are generally the sweet spot we recommend for CS50. 3s are good, and for CS50 AP, it's 2s and 3s is where we want students to end up most of the time. 1s are okay, don't stay in that range, and again, that's something that students are going to quickly stop doing because they like those points, and 0 rarely happens. All right, so I've been talking a lot about grading, and now I want to see what you might be able to do with some sample assignments. So early this morning, I printed out some of my students' code from last year, and I anonymized it completely. We're going to head up to the breakout room and work in groups and think about, if you were to use this metric, analyzing this code based on what we just talked about, what might you assign these various assignments? And upstairs there are some sample assignments. There's the rubric that we would use for this assignment. There's a staff solution, so you can look at side by side what we do differently. You'll notice for this solution that the staff solution that I wrote is longer than the student solution, but maybe you'll see why I wrote it as a longer solution when you get up there. And just to have some practice with this 4-axis model. Again, I know it's not something that can easily be implemented in every high school setting, but it's something to think about even as a metacognitive exercise to add on as an extra on top of it, on top of the other grading that you might be constrained to by your school, just so that students have a more well-rounded picture. Because that's really what this grading philosophy gets at, is not just right or wrong, but why and how. And by splitting things out into multiple axes, we're allowed to do that. So we'll take a couple minutes just to wrap up here, and then we'll head upstairs to the breakout room and do a little bit of the practice of this, just to wind up our our final session together.
The overall grade in CS50 for a student taking it here on campus,
Mm-hmm.
you said there's 2 quizzes and then the problem set?
Right, so in terms of how we weight things, at CS50, it's 50% of the student's grade is their problem sets, 40% on the midterms, and 10% on the final project.
So it isn't the trajectory. So it is not the trajectory.
It is the trajectory. Our grading philosophy is very holistic. So we do care about all these things, but there are a lot of intangibles that come into play too. We do care about, right? It is 50. It is 50.
All 5s, but in problem set 1, they got all 1s. Then they've showed they know.
There are corner cases, of course, right? If a student, I will acknowledge that there is a difference between a student who gets 4s across the board or 5s across the board, and a student who starts out at 3 and has a consistent upward trajectory to 4. The first student is still clearly the stronger performing student, right? Like I think it would be silly to say that it's 3 to 4 is a higher grade because they had a different trajectory. The trajectory element definitely comes into effect.
What I'm saying is, would the student who started with 3s and ended with 4s end with a 4 or an average of all their problem sets? In other words, is it standards based or is it just numbers?
It's holistic.
So at the end, you say.
At the end of the term, we have 800 students, right? I have 20. So we do this. We use these numbers in the syllabus to roughly generate where everybody lands, and then we take into account. Then it's consultations with me. How did the student perform? What was their trajectory like? What was their effort like? We start to take into account the intangibles. So this is the 50-40-10 is our starting framework from which we can then adjust to take into account things like student growth, student tracking. Obviously, at a base level, there has to be a percentage, the 50-40-10 or whatever the scaling different weights are. But that's just the beginning of the grading process. And then at that point, it becomes a lot less numbers and a lot more direct involvement with the student's teaching fellow. And that's why they have the same teaching fellow throughout the term so that they can comment on that student's growth and can point to specific parts of the code. And oftentimes we'll go in to meet one-on-one with David to discuss student grades. So it's hard to describe, it's hard to boil down the way we grade at CS50 at the end of the term, the final letter grade that a student gets, to a simple answer, because there's so much individual attention that we are able to afford to students and we track and care about that comes into play at that time.
On the IDE, I see the sharing, and I was able to find the style 50 by using the same path that you used for the check 50.
Mm-hmm.
So as a teacher, is the process, I know you have a submitting process for edX.
Mm-hmm.
Us at CSAP, at the AP, would we do this grading, use these grading tools by sharing the workspace with our students, or can they submit to our class?
So right now it's been very ad hoc because we haven't known how exactly teachers want to do it.
Yeah.
A lot of folks have wanted to implement or import data into their LMS. And so some teachers are setting up Dropboxes and students are submitting Dropboxes, and those teachers are importing that data into their own workspace and running everything locally. We're trying to, and as part of this template solution that we're working on, is a way to have a submission system that you can access, sort of like how we have a back end to our submission system. Mm-hmm. Similarly, could you have one where your students can submit code, and then hopefully there'll be some sort of option to do that. So
it's great, like we can already get that stuff.
Yeah, it's something that you can do right now, although it may not be the most efficient. We're trying to find what that correct medium is.
That's great, thank you.
Any other questions before we head upstairs? It's really warm in here, isn't it? Is it just me? Maybe it's because all these lights are pointing right at my head. Yeah. All right, well, let's head upstairs to the breakout room, and we'll get into groups. I think we have about 5 people at a table, and we'll just try and practice with this and get a sense of it, and we'll reconvene. I'll do some grading of these as well, just so we can debate the pros and cons of various design philosophies.